All right, so the last lesson in this proportional reasoning unit is on scale factors and how they are affected by three-dimensional shapes. All right, so there's two measurements that have to do with three-dimensional shapes. First one is surface area. And so surface area is, basically if you were to like unfold a box, this box, for example, the area that would be covered by the surface. I guess that's kind of redundant, surface area. And the other measurement is volume. It's the amount of space inside. Now, the kind of like the key factor or key takeaways here is that the surface area of two similar objects is increased or decreased by k squared, because it's a two-dimensional measurement of the surface area. Volume of two similar objects is increased or decreased by k cubed. All right, so this time the scale factor is being cubed because it is volume is a three-dimensional measurement. All right, so so the key thing here is surface area k squared, volume k cubed. So for this example here, we're given the surface area and volume of this larger box, and we want to find the surface area and volume of the smaller box. So first thing we want to do is we want to find the scale factor. Okay, so in this case, that's our first step. Okay, so we have two measurements here. Okay, the height of the boxes. So here's 14 centimeters, the larger one. The corresponding measurement on the smaller box is 7 centimeters. Okay, so therefore, k in this case is, again, it's the new divided by the old, so 7 centimeters divided by 14 centimeters, which is 0.5. Okay. And that kind of makes sense, right? Because 7 is half of 14. So if I took 14, multiply it by 0.5 or a half, I should get 7. Okay, so this is the scale factor. All right, so therefore, now we can find the surface area. So the surface area of the smaller box, what we're going to do is we're going to take the 700 centimeters squared, which is the surface area of the larger box, and we're going to multiply it by k squared. Okay, so in this case, it's going to be 700 centimeters squared times 0.5 squared. Okay, so and to do that, I'm going to need a calculator here. I'm going to go 700 times 0.5 squared. That's going to equal 175 centimeters squared. Okay, so the surface area of the smaller box is 175 centimeters squared. All right. And now to find the volume, I'm going to take, again, the volume of the larger box, which is 1,000 centimeters cubed, and I'm going to multiply it this time by k cubed. Okay, so again, volume gets changed by k cubed, surface area gets changed by k squared. Okay, so in this case, it's 1,000 centimeters cubed times 0.5 cubed. All right, so let's see what that is. All right, so 1,000 times 0.5. Oops, cube button here. I'm just going to multiply by 0.5 3 times. All right, so this would be 125 centimeters cubed. Okay, so that's the new volume. All right, so so the key thing here, takeaway, is that surface area gets affected by k squared, volume gets affected by k cubed. Cool. All right, so there's another example here. So if the volume of a women's basketball is 390.5 inches cubed and the volume of men's basketball is 433.5 inches cubed, how many times larger is the radius of a men's basketball compared to a women's basketball? Okay, so how many times larger is the radius? Now, the key thing here is the radius is a one-dimensional measurement. So in other words, what this question is asking you to do is actually just to find the value of the scale factor k, because we want to know how many times larger when we compare the radius or radii. All right, but we're given the volume. Okay, so we can consider the women's basketball being kind of like the original, and the men's basketball being the new one. So if I was to compare the two volumes, right, 433.5 inches cubed divided by 390.5 inches cubed. Okay, so this is comparing the volumes. So this volume here, when I divide these two, this should be equal to k cubed. Okay, because we are comparing volume. All right, so yeah, let's just divide those two numbers and see what we get. So 433.5 divided by 390.5 equals. All right, so we got 1.110 dot dot dot. Okay, so I'm just going to leave that in my calculator. And now to solve for k, this time I need to take the cube root of both sides. Therefore, k equal. All right, so I need to take the. So I need to take the cube root. Oops. All right, so yeah, so I'm gonna have to use for this calculator here. I could actually use the fractional, but let's punch that in again. All right, so that was k cubed. Now to take the cube root of that, k is going to also equal. This is a little bit of guys review that you may have learned last year. Is the cube root is the same as a fractional exponent of 1/3. So for this calculator, it looks as though I'm gonna have to use this principle here. But for most calculators, you can actually just take the cube root. So anyways, this is going to this to the power of bracket 1 divided by 3. And yeah, so I get k equals 1.03. And let's just round it to 5, 1.305. So this would be the scale factor, all right, of compare the two basketballs. All right, cool. So yeah, so that is scale factors and three-dimensional objects. So again, so let's scroll this back up. This is the key part here. Right? Surface area is changed by k squared. Volume is changed by k cubed. All right.